Okay, and hopefully we are live. One second. Might as well take my earbuds out. What's up, everybody? This is Ryan here, and you're watching another impromptu. Geez, I look like shit. Another random. There goes my monetization. Another random live stream where I'll be rambling about what I've been doing with Jetpack Compose and Kotlin multi-platform stuff. So, basically, let me show you where we're at the moment, and we're just going to dive in. So a couple of the big challenges that I had to deal with here is how do I deal with like moving to different compose screens in the same way that in like an Android application you navigate to different fragments or different activities. So I came up with a pretty quick solution for doing that, which I'll demo in a moment. And one of the big problems that I was dealing with a lot today was that there were certain widgets which are not, how can I say, compatible or easily compatible, out of the box compatible with both the desktop and the Android front ends for Kotlin Compose. Before I get into this stuff really quickly, I just got to mention two things. Number one, I hurt my back this morning, so if you see me randomly wincing in pain, that's what that is. I'm also pretty tired, but I'm going to do my best to get through this because I am excited. So basically, the two things one thing I wasn't able to get to work at all. So unfortunately, if you want to share composables across your desktop front end and your Android front end, constraint layout doesn't appear to work at all. Now there is a ticket in the issue tracker for the Android team to add support for that. And Gabor Varadi at Zwinden actually did some digging into it to see why there was this incompatibility, and it basically has to do with threading. The constraint layout, the current implementation is tightly coupled to the Android main looper. If you're not an Android expert, you probably have no idea what I just said, but basically, suffice it to say that it looks like a problem which should be fixable, but currently that's why that restriction exists. Now, I spent almost 2 days screwing around with one particular thing here, which was getting drop-down menus to work. So what I have come to understand, so typically in a Compose multi-platform project, you're going to have like a common module, usually, and you'll have different source sets. Now, you might have like an Android source set and a desktop source set and an iOS source set, etc. What you'll notice in this application, if you navigate to the Compose UI Gradle subproject in the common Gradle project or module, you'll notice that this is where my actual composable screens are. Almost all of them. So the whole UI, which I will demonstrate in a moment, exists in a common module, and this is shared across the Android and desktop front ends. Now, apart from constraint layout, which I had to just completely strip out of the composables, the other thing I was having trouble with was using drop-down menus. And when I first ran into that issue, I thought to myself, well, come on, this is like a very basic widget. Now, I tried getting it to work myself, couldn't do it. And then I tried implementing some kind of bottom sheet thing, and that didn't work. And then this morning I set out trying to implement this like expandable selection list thing myself, and that didn't work either because nothing I was really looking into seemed to work for both desktop and Android. And then luckily, so the Apache, I'm sure some of you are familiar, a very prolific contributor for Compose stuff, on Twitter suggested that I join the Compose desktop Slack channel in the Kotlin Slack group. And sure enough, after a quick search, I was able to, I read how to actually get your drop-down lists to work in basically this shared UI situation. Shout out to Jim Sprock for that one, who I believe is like the creator of Compose pretty much. So what I had to do is I had to use the expect actual keywords, which are a feature of Kotlin multi-platform. So basically what that looks like is, let me give you just a brief demo of the application so you know what I'm talking about here. And by the way, I had to strip out the constraint layouts, and also I haven't optimized the user interface for desktop, so I know it looks like crap. That's not my major concern right now. I'm going to worry about making it look pretty later. So this is the main screen, and then for example, if I click on one of the hours here, it has drop-down menus, and the reason why this is not working out here is because I need to, this is one of the areas where I stripped out the constraint layout, and I just slapped in some quick uh, row and column type layouts to get this thing working. So don't worry, it'll look better eventually. But in order to get these drop down lists, which you see here, working properly, basically what I had to do is I had to create a, where was that one in particular? That will be the manage hour. So I created a file called task drop-down menu. You don't necessarily need to do this, but I like to pull it out into a separate file. And then I created a expected function in the common source set. So basically what we're saying here is we want the platform-specific source sets to have some kind of function called this, which has these parameters. And then in those platform-specific source sets, so for example, here we are in Android main, then we have the actual implementations. Now, here's kind of the hilarious thing, which is annoying, but at least it works. If I pull up the desktop version and the Android, oops, not that one, the Android version, they're identical. The only reason I actually need to do this is because one of the implementations of the drop-down menu comes from like an Android specific import, whereas the one for desktop compose, uses a different import. Now they look like the same imports on the Surface, but what the Compose desktop plugin does is it actually has some Gradle magic, which kind of maps from these like org.jetbrains.compose artifacts or Maven repository, as opposed to the ones that come from Android X. So anyways, basically just what that means is I had to do something which on the surface looks completely unnecessary, but that's the only way I was able to get drop-down menus to work in these shared composables. So that was one of the big issues I've been dealing with for the last 2 days, and I'm really happy to get that issue sorted out. And the truth is that the fix wasn't actually that difficult to figure out. So big thank you to Jim Sprock for that solution. Now, the other thing I wanted to talk about is how do I actually manage my composables? So what I do is in the Android application, let me just close some stuff down here. In the Android front end, I use activities as feature-specific containers. So each feature, you can think of a feature as like a primary UI screen. What's up, Isam, Gentoo, and Pascal? I use activities as feature-specific containers. So no, it's not single activity architecture. I don't really care. I think it's good to avoid having God activities, but as far as doing single activity architecture for the sake of doing single activity architecture, I don't really think that's very smart. I could have used fragments as containers, but then I'm starting to ask the question, what is the point of the fragment at that point? Because it's no longer a view, it's just a container, and activities work pretty good as containers. But important thing, I'm not filling my activities full of a ton of code. They do exactly what you would expect a container to do. So they call this set content function, and that's what basically binds a composable screen to the user interface. Now, obviously in desktop Compose, we don't have that option. We don't have activities. There's no Android application class. There is an application class. Here I have it in main. Now, what I do, quick question here, no need now with Compose to have fragments or multiple activities. I wouldn't go that far, I mean, you can, I'm sure you can actually implement compose with a single activity. But you would have to figure out some way to swap to the different screens, and that activity probably would end up getting quite bloated, which is why I separate out into multiple activity containers. Anyways, in the desktop version of the application, I had to do something different. I don't have activities to work with, so I can't pass arguments via intents, stuff like that. I have almost zero infrastructure. Now, what I wanted to do is obviously I wanted to reuse pretty much everything common. So here I'm in this application, I'm reusing the view models because they're not Android view models or from Jetpack. I'm reusing the, what do you call it, presentation logic. Oh, sorry, I'm getting a phone call from my girlfriend. Just one moment. I'll be right back. Okay, sorry about that. I just got a call from my girlfriend who got off work super early. So she's on her way home, which means I need to cut this live stream short. Anyways, back to what I was saying. Um, Pascal says you're a coder. Your primary girlfriend is your computer. Um, that was the case a year ago. Anyways, back to the topic here. So, what was I saying? Totally distracted. So, I needed some way to have these activity like containers in the desktop application. And then also, um, I needed to have, I needed to be able to pass arguments between these different containers. And what I arrived at doing is I just created a simple enum. So down here we have the window state enum. And so these can represent essentially what are similar to fragments. So this is how we actually switch between the different screens of the application like I showed you earlier. So what we do is I remember the window state, which again is that enum I just showed you. Now it turns out that all of the features in this application, some of them do require arguments, but the arguments are always an integer. So I have one window args remembered variable as well, which is how I can pass arguments to different features of the application. Now what I do is I have a when statement in the main window of this application, which is sort of a desktop compose specific thing. And basically when the window state changes, we switch to a different window. This is where we then create our composable screen, which is in the common module. And the only other interesting thing going on here is the containers themselves for the desktop version of this application. So obviously I couldn't use activities. I just created simple classes, which, so for example, DayView container, it extends the same interface as the activity containers do. So this is a shared interface here. And it reuses the same presentation logic, the same view model as the Android. And basically what it does is I call this start function to wire the presentation logic up with the view model, and then it fetches the data. And then this is how we actually do our navigation. So let's say, let me just pull this up for a moment. I'll run the application. So here we're in DayView container. Let's say we need to navigate to a specific hour in DayView container. Then all we do is we just click on that, and this function here will get called. So this state handler thing, this is a function type I pass into this container. Now, why did I do that? Well, I did that because I need some way to call back to our remembered state variables up here. So what we do is I give this container, a lambda expression, which does that state modification for us. it redraws, and then we are golden. We're ready to go. So that's all I really want to say about that. Obviously, the application is functioning but ugly. So I'm going to work tomorrow on the user interface to get that looking better. But all of the features, at least the ones I tested, are working. Here I can scroll down to different tasks. I can click on a task. I can change its color. Obviously, this isn't supposed to look like this. Don't worry, I'll get to it. I haven't tried renaming. We'll try rename something. Let's call this dinner, and we'll make it dark blue. If I scroll down, dinner is dark blue. So the state is actually changing. This is an SQLite database for the desktop port. So basically what I'm saying is I'm super happy to get to this stage, and now it's going to be two things just to close this stream off. Two things next. First, I need to fix the user interface to make sure it's looking proper. And then the other thing I need to do is I've come up with this totally new way to manage switching between different features of the application. What I need to be careful with is, am I actually releasing resources appropriately? Is it still sort of performant with respect to memory? I think it is, but how I need to check that is I need to make sure that the old presentation logic classes like this and the old view models that are not currently being used are not being held onto in memory. So with that being said, I have to now, yeah, no kidding, Isam, I have to now leave for some important things. But thank you very much for watching, and hopefully that was kind of an interesting little demonstration of sharing code across Kotlin, sharing compose code across Android front ends and desktop front ends, and some early ideas about how to manage that.